In this video, we are going to talk about inequalities and relationships in triangles between their sides and their angles. So when you have a triangle, so we've learned a few different things, but when you have a triangle, you also have the smallest angle is always across from the shortest side, the medium angle is always across from the medium, and the largest angle is always across from the longest side, on top of all of the other things that you've learned about triangles, that two of their sides have to add up to bigger than the biggest, that their angles all have to total 180. All of those things hold true, as well as these new relationships. So if you look at the diagram here, you'll see, so I drew the angle red. So this 22 is the smallest angle, so directly across from that is the smallest side. So 3 is the smallest side. Then we have the middle-sized angle, so 60 degrees. Directly across from that is the middle-sized side. And then 98 is the biggest degree up here, and directly across from that is the biggest side of 8. Then if you took a look here, if we looked at some of those other relationships, so the 3 and the 7 are the smallest sides. 3 plus 7 is bigger than 8, so this is good, okay? Also, if we added these three angles together, 98 plus 22 plus 60, that would give us, so 98 plus 2 is 100, plus 20 is 120, plus 60 is 180. So we do have the interior angle sum of a triangle as well. So all of these things need to hold true every time you see a triangle. So let's take a look here, and this one wants us to find the smallest angle. Okay, so we are given all three sides. So to find the smallest angle, we would look for the smallest side length, and then directly across from that is going to be the smallest angle, in this case, angle L. The largest angle, again, would be across from the biggest side being 10. So directly across from that side is going to be the biggest angle, in this case, angle J. Next one, so this one wants the longest side and the shortest side. So we are going to have to find the biggest angle and the smallest angle. So now there's only two angles given here. So what we need to do is figure out how big this third angle is, C, to determine if that is bigger or smaller than either of these two. So we know that the total is 180. So we will do 180 and subtract off the 98 and the 50 to get us our leftover of 32 degrees. So this angle in here is 32 degrees. So angle C is 32 degrees. So 98 is definitely the biggest angle. So across from the biggest angle will be the biggest side. Now remember, the side is this whole segment here. Okay, and we name a segment with its two endpoints with capital letters and a picture of the segment above it. Shortest side is going to be across from the smallest angle. So now we see 50 and 32. So we know 32 is the smallest angle. That was in angle C, so right here. So across from angle C is the shortest side. Okay, so this side right here connects point A and point B. So segment or side AB is the shortest side. You don't have to know the actual lengths to determine which one is bigger or smaller. This one says place the given measurements correctly on the diagram. So again, so we're given all of the sides, so we can start to analyze the angles versus the side lengths. So this 13 is the biggest. So across from the biggest side needs to be the biggest angle. Okay, and the biggest angle over here is 98 degrees. So we would pull 98 into that angle. Then you can look at the smallest side, which is the 7. Okay, so across from the smallest side is the smallest angle. So 32 is the smallest angle. That would go here. And then that would leave the middle sized, or this last angle, to go here. Now, you might think this looks way bigger of an angle than this one does, right? But the picture doesn't have to be drawn to scale. You need to go by the actual measurements of the sides given to you. So this one was labeled as 13, so this is the largest angle, even though the picture kind of doesn't really look like that. All right, another one to place the given measures here. So now we have a combo of side lengths and angle measures. So we see this 90-degree angle here. So remember that that's 90 degrees. That automatically has to be the biggest angle, okay, which we can see 37 and 53. None of them are bigger than 90, and they never can be. So across from this 90-degree angle is going to be the biggest of the sides. So this 5 will go there. Then that only leaves the 3 left for sides to fill in. So we know the 3 goes here. Then you can take a look at your smallest side if you wanted to. So smallest side across from that is going to be the smallest angle. So the 37 is the smallest of the angle measures given. And then 53 would fill in here across from the middle-sized side. All right, then let's take a look at a couple diagrams to decide what's wrong. So remember, I started the video talking about all of the things that you should know about triangles, so you're going to want to check those along with our new idea here. So first thing I would do really is probably just look with the new information are the longest and shortest sides across from the biggest and smallest angles. So when we look here, the biggest side is the 13. That should be across from the biggest angle, but the biggest angle is this 90-degree angle. So across from the 90-degree angle should be the biggest side. So that's a problem in this one. Okay, so the 13 should be across from the 90-degree angle, so across from the 90-degree angle because this is the biggest. So longest side should be across from biggest angle, so that's the issue there. Next one, so again, I would start with that. So look at, here's your biggest angle is 100. So across from it should be the biggest side, 23. So is 23 the biggest side? And it is. It's bigger than the 10 and 20, so that's good. So then we can look at the smallest angle. Okay, smallest angle here is, so across from the smallest angle should be the smallest side. So is 20 the smallest side? And that would be a no. Okay, so the 10 should be opposite or across from the 40-degree angle. And there's actually another mistake in this one if you see it, is that the angles actually don't total 180 either. So 100 plus 40 plus 60 does not equal 180 degrees, and it always has to in a triangle. So this one doesn't have the correct sides across from the correct angles, but it also doesn't have the correct interior sum. Next one, so take a look here. So across from the biggest angle, well, in this case, we have all 3 degrees are 60. So all of the angles are the same. That means that all of the sides need to be the same because there isn't a biggest or a smallest angle, okay? So they would all need to be the same, so that's a problem, okay? So equiangular means we have to have, means it has to be equilateral. And it's not. And then 60, 60, 60 does total 180, so the interior sum is good there. Okay, next one. So let's take a look at the biggest angle here is 80. So across from the biggest angle is not the biggest side, so that would be a problem. Okay, so biggest angle isn't, whoops. across from biggest side. So that could be an error that you saw. And I mean, the smallest is across from the smallest, but biggest isn't across from the biggest. Another thing you may have checked is the interior sum, and 50 plus 30 plus 180, or sorry, 50 plus 30 plus 80 does not equal 180. So that could have been an error that you saw as well. And then another error that you may have seen is the two smaller sides here. So the two smallest sides actually don't add up to more than the biggest side. So 3 plus 2 is not bigger than 6, which it needs to be to have the sides even create a triangle. So a lot of errors in that one that you could have seen. Any of them would have worked to say why this diagram is a problem.